Algebra 2, this is Chapter 5, Section 6. This is the third of 7 videos. It's going to be the second example. This is how to simplify a quotient. So just like the multiplication, we can split this out to be the square root of y to the 8th over top of the square root of x to the 7th. I know we're doing with square roots, so square roots is basically a 2, so you're looking for even numbers. This x to the 7th is not even, so I'm going to have to get my denominator into an area that I can work with. So I'm going to have to multiply this by the square root of x and multiply this by the square root of x in order to get the 7 to be an even number. So now this becomes the square root of y to the 8th times the square root of x over the square root of x to the 8th. So now there's lots of stuff we can reduce. The square root of y to the 8th, 8 divided by 2 is 4, so this is just a y to the 4th. You can't do anything with x, the square root of x, so we just write the square root of x. And in the bottom, we've got the square root of x to the 8th, so that is x to the 4th. And that one's as far as it goes. Let's look at another one that's similar to that, except for it's cube rooted this time. So now we're looking for groups of 3. Well, 9 is 3 squared, but we're going to have something that's cubed. So we're going to have to multiply top and bottom by something that will make us have groups of 3. So we already have 2 3's in the 9, right? Because that's 3 times 3. So I need to have another 3 to make that a cube. X is x to the 1st, but I need it to be x to the 3rd, so I have to multiply by x squared. And whenever I do the bottom of my fraction, I'm going to have to do the top of it. So I have to multiply this by 3x squared on top. Okay, so whenever I do this, this is going to be, and these are all cube roots, by the way. This all has to be cube roots, so this doesn't work. The top is going to be the cube root of 2 times 3x squared, putting all that under the radical. And the bottom, it's cube root here, cube root, is going to be a 3 times a 3 times a 3, right? The 2 3's from this 9 and the 3 that's right here. And then it's going to be times x times x times x. Now remember, since it's cube rooting, we're looking for groups of 3. So I have 3 3's, so I can put a 3 on the outside of my radical. I have 3 x's, so I can put an x on the outside of my radical. And then I don't have any groups of 3 on the top, so the top is going to stay something ugly. So it's the cube root of 6x squared. And that's as far as I can take that one. That is called simplified. We have no radical in the denominator, and the numerator is reduced as much as possible. Let's look at another one. So again, my denominator, I can't just take the square root of y to the 5th because 5 is odd, and we need, since it's a square root, even numbers. So I need to multiply top and bottom by the square root of y. And so I'm going to simplify this. The square root of x to the 4th is x to the 2nd. I can't do anything with the square root of y. And this bottom becomes the square root of y to the 6th, which I can then reduce. So this is going to be x to the squared times the square root of y. That's simplified. And the square root of x to the, or y to the 6th reduces to just y to the 3rd. There are 3 groups of 2. And that is simplified form. The bottom has no radical, and the top is as simplified as it gets. Last one of these, I want to do a 5th root. 5th root means I want groups of 5. And 4 is 2 times 2. So I need 3 more 2's because I need 5 2's. So I'm going to take and multiply by 3 more 2's, so that's 2 cubed. And whenever I do the bottom, remember I have to do the top. And notice it doesn't matter if I make 1 radical or if I make 2 radicals for the numerator and the denominator. And then I've got 1 a, so I'm going to need 4 more a's to get that group of 5. So again, whenever I do the the denominator, I have to do the numerator. So this is what I'm multiplying by. So when I multiply this, I now have 1, 2, 3, 4, 5 2's. So that's going to bring the 2 on the outside. I have 1a here and 4 a's here. That's going to give me a total of 5 a's, which is going to put an a over here. And then on the top, I have a 5, and I have a 2 cubed, and I have an a to the 4th. None of this, oh, by the way, that's supposed to be a 5 there, sorry. None of that reduces. So on the top, I'm going to have the a to the 4th underneath the 5th root here. And then I'm going to have 2 cubed. So 2 times 2 is 4, times 2 more is 8. This is going to be 8 times 5. That's going to give me 40. So that's 5 times 2 cubed, which is 5 times 8, which is 40, which is where I got that 40 right there. Okay? And the a to the 4th just stayed. On the bottom, remember this is a squared, or this is 2 squared times 2 to the 3rd, which is 2 to the 5th. And we take the 5th root of 2 to the 5th, you just get 2. And this was an a here, times a to the 4th, which is a to the 5th. And when you take a 5th root of a to the 5th, you just get a. Now, hopefully that's clear, and you've gotten the same answer. This is as simplified as it gets. No radical on the bottom, nothing more I can reduce on the top. A couple more examples here before I go on, because this seems to be a fairly complicated thing. And this is one of the areas where you guys get stuck. So 81, and you'll start to remember these, 81 is 3 to the 4th power. If you can't get right there right now, know that this is 9 times 9, and 9 is actually 3 times 3. You will have these memorized because you will use these enough that you will get to there. So this is going to be a 3 to the 4th on the bottom. So this is the 4th root, so we're looking for groups of 4, of 1 over 3 to the 4th. And then this is going to be c to the 4th times c and d to the 4th. Why did I do that? Well, again, I'm looking for these groups of 4. And I know c to the 5th is 4 plus 1, so I just broke it out. So I'm getting ready to take them all outside. So 1 can be 1 to the 4th, doesn't matter, so I'm going to bring my 1 outside. 3 to the 4th, well, that brings a 3 outside. C to the 4th, that brings a C outside. D to the 4th brings a D outside. And the only thing I can't take outside is that 4th root of C. And then I don't really have to put this 1 right here. I could erase that. And that would be my final answer. I don't know, can I move my 3 here? Nope, my 3 is attached to my C. I can ungroup it. And then move my 3. So that neatens up my final answer. One more example here. So a 5th root. And I know 32 is 2 to the 5th. Again, you will get there. You're probably not there yet. So if you're not ready for that, you know that that's 4 times 8. Okay, and then the 8 is 4 by 2, and the 8, this 4 comes down to a 2 by 2. So I've got 1, 2, 3, 4, 5 2s, so in fact 32 is 2 to the 5th power. Okay, so I'm going to rewrite this expression now that I've gotten my 32 where I need it to be. I'm looking for groups of 5 because it's 5th root. So 32 is 2 to the 5th. W to the 6th is W to the 5th times 1 more W. And Z to the 7th is Z to the 5th. And then I would need 2 more Z's to make that 7. Once I get to this point, I can start taking out my groups of 5. So 5 groups of 2 would leave me just a plain 2 on the outside. 5 groups of W is going to leave me a plain 5 on the outside. And I've got my 5th root here. I'm left with this 1 W on the inside. This Z to the 5th becomes 1Z, Z to the 1st on the outside, and Z squared is left on the inside. Okay? And that is the final answer to that problem. Okay, I've got two more examples, and then I'm going to finish up here with taking the simplified quotients. So I've got a fourth root here, and I've got a 3 on the bottom. I have 3 to the first. I need to get to 3 to the fourth, so I need 3 more 3's. So I have to multiply top and bottom by 3 more 3's, all under the radical of fourth root. So that's going to be a fourth root with a 2 on the top, times, and 3 cubed is 27. 3 times 3 is 9, times 3 more is 27, over the fourth root of 3 to the fourth. And there's nothing up here. 2 is not a fourth root. 27 is 3 to the third, not a fourth root. So 2 times 27 would be 54. So this is going to be the fourth root of 54 on the top. And I've got 4 sets of 3. I need 4 sets of 3 to take them out. So that's just a 3 in the bottom. So that one is simplified. Last example here. So this is a square root, right? There's nothing there, so we assume that's a 2. So we want groups of 2. I have a 3. I need one more b here to make that into a 4. So this is going to be the square root of a to the fourth times b over b to the fourth. So the square root of a to the fourth, groups of 2. There'd be 2 groups of 2, so that's a squared coming out with a b left inside. And I need groups of 2, so that would be b squared left on the inside. Hopefully with all these examples you've figured out how to do the quotients.